Today's lesson is 2.4, rotations and dilations. Let's go ahead and start with rotations. An image and its pre-image before rotation are congruent. They are congruent. Remember, this is the symbol for congruent, which means that they are equal. All right. We're going to do two things. We're going to identify some key points in our pre-image. That is the image that we see originally. That is the figure that we see originally. And then we're going to create the image such that each point is rotated the correct number of degrees in the correct direction. Before we start, let's go ahead and talk about clockwise and counterclockwise. Remember, on my standard clock, 12 is here, 3 is here, 6 is here, and 9 is here. Here's 1 and 2, 4 and 5, 7 and 8, 10 and 11. When I go in this direction, starting with the 12, and I go towards the 1, 2, 3, 4, 5, 6, I am going clockwise. And when I go this direction to the left, 11, 10, 9, when I'm counting backwards, then I'm going counterclockwise. So that's the difference between the two. All right, our first example is to take this figure, which looks like the letter A, and we are going to rotate it 90 degrees clockwise around the origin. So notice it says a couple of things. It's telling us to go 90 degrees clockwise. When you're thinking of degrees within your coordinate system, when you go from one coordinate to another, it doesn't matter which coordinate you go to, but when you go from one to another, you are going 90 degrees. So to take this 90 degrees, I'm going to go into this quadrant, or I'm going to go into that quadrant, depending on the word that it says. Well, it's saying clockwise, so I want to go to the right. So I'm going to bring it into this quadrant. And I need it to stay in this first quadrant. It cannot go down here because that would be 180 degrees. So this would be 90, 180, 270, 360, all the way back around. Okay, that's what you're kind of thinking of. All right, and then it says about the origin. It's always going to give you a place of reference. So I'm going to go right here to the origin, and I'm going to put a little purple dot. And I'm doing this because you can use that dot, that point that you're going to rotate around as a reference, or you can use a little trick. So I'm going to show you two different things that you can do. All right, so let's start here with the corner. And what you could simply do is count how many it's over to the axis, which is 1, and then 1, 2, 3, 4. So you're going to do that opposite. So notice I went 1 to the left, to the right, and then 1, 2, 3, 4 down. So I'm going to reverse them from where the origin is. I'm going to go 1, 2, 3, 4, and 1 down. And I'm going to simply place it right here. So that's, well, no, I'm sorry, that's wrong. I'm going to go 1, 2, 3, 4, and 1 up. I'm going to go right there. I'm sorry. So 1, 1, 2, 3, 4, and then I'm just going to go backwards. 1, 2, 3, 4, 1 up. There we go. So it's kind of like if I'm going to count, I'm going to do it backwards. Another way that you could do this is you could look at your ordered pair. The ordered pair in the pre-image is -1, +4. When I go to rotate it in my image, notice that it is 4, comma, +1. So the X and the Y switched places, but then I need to be, my Y value changed from -1 to +1. Why? Because if I kept it -1, then my image would be in the wrong quadrant. I would have over rotated. So I just have to be aware that quadrant 1, which is where I'm putting my my new image, has to be positive, positive. Okay, so I just need to be aware of that. So two different ways. We can count 1, 1, 2, 3, 4, 1, 2, 3, 4, 1. So we just count it kind of in the opposite way. That's one way we could do it, or we could use our ordered pairs. So let me show you that one more time. Let's go ahead and try, let's try this guy right here. So 1 over, 1 up, 1 up, 1 over. There it is. Or if I do my ordered pairs, I have -1, -1. Remember, it's going to rotate from quadrant 3 to quadrant 2. Quadrant 2 is a negative x and a positive y. And I have -1, +1, which is exactly what we said we were going to have. So there it is. Now, of course, once you have a couple of points in here, you could use that same idea. It's 1 away, so there's 1 away right here. This one is 2, so you can count 2 in this direction. And you can just kind of use your shape and create your letter A. This one would be the same as this one. And then we're going to count up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There it is. And we're going to count it. There's the outline of my A. Oops. There's the outline of my A. I've just got to get it right in here. There's the middle part right there. There would be my middle, right? But you could do the same thing with your counting, or remember you can switch the X and the Y. You just got to pay attention to the quadrants and what kind of signage the quadrants would have. All right, let's go ahead and try another one. So this second one with the letter A is asking me to rotate the figure 180 degrees around the point N. 180 degrees around the point N. Okay, so there's my point N, and here is the top of my A. If I were to go 90 degrees, 1, 2, 3, it would go simply straight up like this. Okay, if I were to go 180 degrees, then it would go like this. So you kind of got to imagine that this is going to do that, which is going to take your letter A and flip it in this direction. Something like this is what it's going to look like. So this point's going to stay, but 1, 2, 3 away, 1, 2, 3 away is the other part of my A. There we go. This is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 up. There we go. 1 over. 1, 2. 1, 2. 1, 1. 2 again. 2 again. 1, 1. Then all the way down. And my box for my A is right there in the middle. Now, I know it didn't say to go counterclockwise for this one, but it just seemed kind of natural to go counterclockwise. If I were to have gone clockwise, then it would have looked even funkier. So it would have come down 90 degrees like this, and then it would have come no, I think it would have been the same actually. Actually, yeah, it would have been actually the same because 180 is the same. 180 is the same, right? 360 divided by 2 is 180. So it doesn't matter if I go this way clockwise or that way counterclockwise. It doesn't matter. All right, the last one, and this one is probably the hardest because it is asking me to rotate 90 degrees around a specific point. I'm going to go ahead and put the point here, 1, -2, there we go. And I'm going to use my counting method again. So let's take this guy right here, and we're going to count like rise and run, overrun. So 1, 2, 1, 2. So I'm going to go 1, 2, 1, 2. There we go. Yes. Just double checking. And then I'm going to use I'm going to use the fact that this one is 1, 2, 3, 4, 5, 6, 7, 8 up. But because we're going clockwise, it's going to actually go 8 in that direction. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. There we go. And then the last thing I need is this point right here. From that last point that I counted, it's 1, 2, 3, 4, 1, 2. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. It's going to be right there. 1, 2, 3, 4, 1, 2. There we go. And there we go. There it is. Take your time. Be as careful as possible. Rotation. All right, the last one that we're going to talk about today is dilation. A dilation is a transformation that produces an image that is the same shape as the original. It stretches out or it shrinks the original figure. A dilation is not an isometry, um, except in special occasions. All right. The properties of dilations. Uh, the description of a dilation includes the scale factor, how much you are going to stretch or shrink it, and the center of dilation. What are you going to dilate it around? We normally see that written as capital D, where this right here would be my center. So my center is at 0, and this right here is, of course, my scale factor. If the scale factor K is greater than 1, my dilation is called a dilation. That does not sound right. I'm going to fix that in class, but that doesn't sound right. If the scale factor K is between 0 and 1, my dilation is called a contraction. Yeah, I'm thinking that dilation is not correct. All right, so let's go ahead and take a look at our first example. Find the image of ABC under the dilation D0, 2. So you always want this center to be at 0. That's not going to move your point much. And then your scale factor is the 2. Basically, what that means is you're going to take each part of your ordered pair and you're going to multiply it by your scale factor. So let's go ahead and start with our image. So -1, 0, 2, 2, 3, -2. So there's A, there's B, there's C. Let's connect it together to make our triangle. There we go. Perfect. And now we're going to go ahead and we're just going to multiply by that scale factor. So there it is. There's our scale factor. -1 times 2 is -2. 0 times 2 is 0. So -2, 0. Here is A prime. 2 times 2 is 4. 2 times 2 is 4. B prime is at 4, 4. There it is. And 3 times 2 is 6. And -2 times 2 is -4. So 6, -4. There is C prime. And then we can just go ahead and connect them together to create our image. That's it, there's our dilation. Let's try one last one. Find the image of a triangle ABC under the dilation 0, 1/2. So this right here, once again, is my scale factor, which just simply means I'm going to take each point, A, B, and C, and multiply everybody by 1/2 or divide by 2, because remember that is the same thing. You always want to start By graphing your image, don't forget, or your pre-image, sorry, don't forget that you want to label them as A, B, and C so that you know what happens to A, what happens to B. So there we go, and of course what happens to C. So let's multiply 1/2 by 1/2 or divide by 2. That would be -1 and 0. There is A prime. 1 comma 2, 1 comma 2, there would be B prime, and 2 comma -2, there would be C prime, and they all connect into this triangle.